GMAT Tuesdays with Kevin, me. We're back in the Berkeley Magoosh headquarters, and today we're going to do a tour through geometry. If you come to the Magoosh GMAT blog a lot, you probably saw this challenge question that was on the side of the website, and I want to work through the problem with you so you can see how to solve it. And the reason I'm calling this a tour through geometry is because that's kind of what it is. This type of question is really just seeing how much of geometry do you really know. So first, the question. It says, if ABCD is a square with the area of 625 and CEFD is a rhombus with an area of 500, then the area of the shaded region is... And we have our options here. So important things to pay attention to. 1, figure not drawn to scale. That means it's not exactly like a square because I can't draw very well. And even on the test, they will have this information there. So you really don't want to trust what you see. You want to trust the numbers and your knowledge of geometry. Other things we want to notice. We're dealing with a square, and we're told the area of it. And we're dealing with a rhombus, and we're told the area of that. And then it's always good to kind of take a quick glance at the answer choices just to see what is here. Okay, so it's going from smallest to largest, 125 at the lowest end, 275 at the high end. One thing, sometimes you're running out of time on the test, or you want to catch up, you're pacing yourself and you know you need to catch up and move through a question quickly, so you might have to guess. One thing that I would do to help my chances of guessing with this type of problem is I can see 625 and 500 here, and someone who's not thinking very clearly or is rushing might think, oh, the area of this part here is just 625 minus 500, so it's going to be 125. That is a trap. That's a trap answer right there. So you can immediately get rid of that answer choice, and then at least you're choosing from 4 instead of 5 answer choices. Then maybe you can do some other stuff to eliminate those other possible answer choices. Okay, so with math problems, it's always helpful for myself to kind of get a sense of what I'm going to do. I want to come up with like a roadmap or a plan for attacking the problem before I actually start doing the problem. One mistake that students often make with math is they just start doing stuff without really having an idea of where they're going, and that can end up wasting a lot of time because you might go down the wrong path and then have to go back to the beginning and start over. So ultimately, if you spend just 15, 20 seconds at the beginning figuring out what you need to do and then doing it, you'll probably save time in the end. So ultimately, I know I'm dealing with a square, a rhombus, a triangle, and a rectangle. So what I'm going to do here is basically I'm given the areas, so I know I'm going to have to find the sides of these shapes. I also know that I have right here, if I draw a line right here, let me make that easy to see. I have a rectangle now, and then a triangle. And so if I find the area of this rectangle and the area of this triangle and add them together, then I'll know what the area is of these shaded regions. And so I have these mystery sides that I need to figure out for the square and the rhombus. But since I have the area here, I know that I can do it. So that's my plan, and let's just dive in and do it. So the area of the square is 625, and if you guys remember what the area of the square is, it's the length times the width. So that's going to be 25 times 25. So now I know, okay, I've got a 25 length there, 25 there, 25 here. Awesome. So I'm pretty close to actually solving the area of this rectangle here. I just need to find out what that... Oh, that's really ugly. Let's try that again. Bam. Okay, so I need to find the length of this part right here. I know the whole thing is 25. If I knew the height of my rhombus, then I could subtract the 25, or excuse me, the height of the rhombus from 25 and know that there. So, who remembers what the area of a rhombus is, or how to calculate the area of a rhombus? Anyone? Anyone? Oh, yes! It's the base 25 times the height. So I know the area of the rhombus is 500. I know that the base is 25. And so what times 25 gives me 500? It is 20. So now I know that the height here is 20. So that means that this is going to be 5. Great. So now I know that the area of the rectangle is 25 times 5 times 5, which is equal to 125. Excellent. So now all I need to do is find the area of this triangle and then add it to 125 and I'll have my answer. So area of a triangle is 1/2 base times height. So for this triangle here, I have the, let's see, what do I have here? Oh, I know that this is 20 because this is 5. And a rhombus is like a square. It has all equal sides. So this is actually going to be 25. And then I can use the Pythagorean Theorem to get this side here. So let's do a squared plus b squared equals c squared. So we have 20 squared plus b squared equals 25 squared. This is 400 plus b squared equals 625. B squared, whoa, that's really ugly too. Looks like a 5. B squared is equal to 625 minus 400, which is 225. The square root of 225 is, anyone? 15. All right, so now I know that this side is 15. Put it up here. Draw an arrow. All right, and now I can solve for the area of the triangle. So 1/2 base is going to be 20 times 15. So 1/2 of 20 is 10. 10 times 15 is 150. All right, are we done? No. Last part, we got to add these two together. 125 and 150, which gives me 275. And my final answer then is 275. All right, excellent. I hope that you understand this problem a little bit better now. A lot of times on the GMAT, they give you, you have to know a lot about geometry and be able to work at problems in different directions. And this is pretty normal where you're working with different concepts and you're combining them and having to do multiple steps to get to your final answer. So, have a wonderful day. If you guys have any questions or comments or suggestions, please put them down in the comments. We'll be happy to answer them. Be excellent to the universe, and I will see you next week.